Yes, ma'am. Yes, ma'am.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
27 slides. Counting the slides.
Namaste. Good morning, everybody. It is a great pleasure for me to introduce you all to the speaker of the day today, Sai ESHWARI Madam, Principal, Telangana Model School and Government Junior College, Munagalla, Suryapet District, the erstwhile Nalgonda District. Madam is a very eminent teacher, administrator, and all-rounder in the field. She's been a senior teacher of mathematics at various levels, intermediate, school level, and higher levels. Just as the madam is going to take up straight lines today, just as straight lines, it takes up various shapes. If it is in the side of a triangle, it is a side of a triangle. If it is joining the circle through the diameter, it becomes diameter. If it is touching the circle, it becomes a tangent. Like this, number of shapes and number of roles straight line is actually taking up. So also Sai ESHWARI Madam, while teaching, she is an excellent teacher. As an administrator, she is an excellent administrator, and such multifaceted role that she plays. She is before us today to conduct today's webinar on straight lines, and I am sure all the children would enjoy the class and they will be able to get maximum out of today's webinar. Madam, Sai ESHWARI Madam, welcome to you, and please take over the session, Madam. Thank you.
Thank you so much, sir. That was very nice of you. And good morning to all the viewers and all my team members.
My pleasure.
It takes me immense pleasure to present before you this topic, straight lines. As Krishna Kumar sir has told, straight line takes up different roles and different types. Now, what do we have here in our plate today? Let us see. So here we are going to go with lesson 1. So today our topic is going to be about straight lines. Yeah. So what are we going to learn today? So we are going to learn about slopes of a straight line, slopes of parallel and perpendicular lines, and different forms of straight lines. This is what we are going to learn today. And this is not a completely new topic to you because you have already learned certain things about straight lines in your 10th class itself. Now let me give a quick revision of what you have learned in your 10th class, and let us look into the simple basics of straight lines. Now, as you all know, the coordinate plane is divided into 4 parts with 2 axes, namely the x-axis, which is called the horizontal line. The horizontal line is called x-axis. And we also have the vertical line, which is called the y-axis. Is it not? Yes. We have x-axis, the horizontal line, and the vertical line is called y-axis. Now, the point of these 2 lines, you must be knowing, you must be guessing by now. It is called the origin. So what is origin? It is the point of intersection of these lines, x-axis and y-axis. Now, we have to learn more about equations here. So here, the equation of x-axis is y equal to 0. The equation of y-axis is x equal to 0. Why like this? If you observe on x-axis, each and every value of y is 0. There is no y value, is it not? All the values on x-axis are x values only. So none of the y values are present. And each point At every point on x-axis, y is 0. That's why we call the equation of x-axis as y equal to 0. Similarly, the equation of y-axis is x equal to 0 because every point on y-axis, you're going to have the value of x 0. Now, what about the lines parallel to x-axis? See, here we have two lines which are parallel to x-axis, one above x-axis and one below x-axis. As you know, again, all the values on this particular line will have only that particular value of y, is it not? So here, every value of that point, y will be equal to k, y will be equal to k, and we have the equation of the line parallel to x-axis above x-axis as y equal to k. Now, similarly, the value of a line parallel to x-axis below x-axis will have a value y equal to minus k, and so you can define this line as y equal to k. Now, here at this juncture, we will see also the lines parallel to both x-axis and y-axis. Yeah. So yeah, the equation of the line parallel to x-axis is y equal to k. And similarly, we have lines parallel to y-axis, and the equations of the lines parallel to y-axis would be x equal to k and x is equal to minus k. So here what we learn from this slide, we have to learn that the equation of x-axis is y equal to 0, equation of y-axis is x equal to 0, and any line parallel to x-axis will be of the form y equal to plus or minus k, and any line parallel to y-axis will be of the form x is equal to plus or minus k. Now, let us see the definition of a slope. This is something what you have already learnt in your 10th class. Now, I go by the definition in the textbook. If a non-vertical line, straight line L, makes an angle theta with the x-axis measured counterclockwise from the positive direction of the x-axis, then tan theta is called the slope or gradient of the line L. The slope of a non-vertical straight line is usually denoted by M. So this is the definition of slope of a straight line. Now, how does it look like? Let us see. We have got x-axis and we also have y-axis. Now, there is a line which is intersecting both x-axis and y-axis, and it is making an angle theta with x-axis. This line L is making an angle theta that is in the clockwise direction, or no, anti-clockwise direction. Usually we take the anti-clockwise direction as the positive direction, which is here given as counterclockwise. So you must have learned in your physics about units and dimensions, where you will learn that if an angle measured in the anti-clockwise direction, that angle is called a positive angle. Now, what happens if you measure the angle in the clockwise? Now, if you measure the angle in the clockwise direction, obviously it is going to be a negative angle. So here we are particular about taking the angle in the anti-clockwise direction. Now, if a straight line makes an angle theta with the positive x-axis in the positive direction, and a tan is taken for this particular gradient, then that tan theta is called the slope of the line. Now, the line can be like this, which is making an acute angle, or it can also make an obtuse angle like this. Even then, we will be measuring the angle in the positive direction only, that is the anti-clockwise direction, and for which we will be taking tan theta, which is called the slope. Now, this is what you have learnt in your 10th class also. So here, my dear children, be sure of this definition. Any straight line which makes an angle theta with the positive x-axis in the positive direction. Remember, these two words about positive. positive x-axis in the positive direction. A tan value taken for that always gives you the slope. Now, when we have this definition, now what about the slope of x-axis? Now, what is the angle made by x-axis with itself? See, the angle made by x-axis with itself is going to be 0, is it not? So, what is tan 0? Tan 0 is a value which gives you 0. So, the slope of x-axis is 0. Similarly, if you take the slope of y-axis, if I want to find the value of y-axis, now here this y-axis makes an angle 90 degrees with x-axis. And so tan 90 degrees, as you know, is undefined or infinity. The slope of y-axis is either undefined or infinity. So here, what are the 2 points that we have to stress in this slide? One is slope is the tan value taken to the angle which a line makes with positive x-axis in the positive direction. So m equal to tan theta. This is one point you have to put it in your mind. And on applying this for x-axis and y-axis, you should remember that the slope of x-axis is 0 and the slope of y-axis is undefined or infinity. Now, what happens to other lines? Now, we have two particular cases where the lines are parallel and the lines are perpendicular. Now, let us see how the slopes of the lines of parallel lines would look like. So, here I have taken x-axis and y-axis on which there are two parallel lines. Now, this x-axis is acting as a transversal to them. And so, the angles made by these parallel lines, let us call them theta 1 and theta 2. Now, can you guess what will happen with theta 1 and theta 2? As I've been telling you, these lines are parallel and this x-axis acts as a transversal. You will observe that theta 1 would be equal to theta 2. Yes, why? I hope you remember these are nothing but corresponding angles. So corresponding angles would be equal, and so if two lines L1 and L2 are parallel, then the slopes made by these lines, the angles made by these lines with the x-axis would be equal. Now if they are equal, let's take tan on both sides. So the tans also would be equal. So if theta 1 equal to theta 2, then obviously you will have tan theta 1 equal to tan theta 2. Is it not? If tan theta 1 and tan theta 2 are equal, what is tan theta according to the previous slide? According to the previous slide, tan theta is nothing but its slope. So if I call m1 as the slope of the first line and m2 as the slope of the second line, obviously this implies m1 would be equal to m2. So here what do we understand? If two lines are parallel, then their slopes are equal. Now the other way around is also true. If the two slopes are equal, if I have two lines whose slopes are equal, which means m1 will be equal to m2, which means tan theta 1 equal to tan theta 2. Obviously, I can say theta 1 is equal to theta 2, and hence L1 would be parallel to L2. So this is other way around also. If the lines are parallel, then the slopes are equal. If the slopes are equal, then the lines are parallel. So vice versa, you have to remember this. So whenever you have a question about parallel lines, please to remember that the slopes are equal for parallel lines. Now what happens to perpendicular lines? Let us see. See again, I have x-axis and y-axis. Now I have two lines which are perpendicular to each other and they are making angles theta 1 and theta 2 in the positive direction with the positive x-axis. Now the angle between these two lines is 90 degrees as they are perpendicular to each other. So if these two lines are perpendicular, what happened with theta 1 and theta 2? You can see there is a small right angle triangle here. So I can have this particular, what would be the relation between theta 1 and theta 2? Obviously, you will have theta 1 is equal to 90 plus theta 2. And so taking tan on both sides, tan theta 1 would be equal to tan of 90 plus theta 2. You will learn about the derivations of all these tan of 90 plus thetas in your trigonometry. Okay. Now, just remember tan of 90 plus theta 2 is minus cot theta 2. And you know, tan and cot are reciprocal to each other. You have learnt in your 10th class. Cot is nothing but 1 by tan. So bring the tan to the other side, that is the left side. You will see that tan theta 1 into tan theta 2 is equal to -1. Again, if I say M1 and M2 are the slopes of the perpendicular line, here you can see M1 into M2 is -1. So here what do we understand? We understand that the product of slopes is equal to -1. So here the bottom line is, if L1 and L2 are two perpendicular lines, then the product of slope is equal to -1. Now the other way around is also true. Now somewhere if you find the product of slopes is equal to -1, obviously the lines are perpendicular to each other. Okay, so dear children, from this slide, please remember that if two lines are parallel, then the slopes are equal. If two lines are perpendicular, then the product of their slope is going to be -1. Okay, parallel, slopes equal. Perpendicular, product equal to -1. This is what we are supposed to learn from this slide. Now, let us see if I have got 2 points. See, somewhere in a question, you will be given 2 points on a straight line and you will be asked to find the slope. Now, this I hope you must be remembering after a long, long break of Corona. Somewhere you must be feeling that you have learnt in your previous Janma. Is it not? But you know this formula, just watch it. So you have 2 points called x1, y1 and x2, y2 in space. Now suppose I have this as x-axis and this as y-axis. And now this is a line which is passing through the 2 points. And this line is making an angle theta with x-axis. Now here, if I draw a line parallel to x-axis, this angle is also going to be theta. Now let me draw perpendiculars from these 2 points, E of x1, y1 and B of x2, y2. Then the perpendicular, foot of the perpendicular here on x-axis would be x1 and the foot of the perpendicular from B would be x2. Now the distance here, I have a small right angle triangle. So this part would be what? It would be just the difference of these two things. Is it not? From here to here, this is x2. And again from here to here, it is x1. So the difference is going to be simply x2 minus x1. And with the same explanation, if again we drop a perpendicular from A and B here, now again this portion is going to be y2 minus y1. Now in this small right angle triangle, suppose I take tan of that particular angle in the triangle ABP. Now what is that I have? What is that I have? So I have tan theta is equal to opposite side by adjacent side. Now here for tan theta, the opposite side is y2 minus y1 and the adjacent side is x2 minus x1. Ma'am, I hope I am audible, ma'am.
Yes, ma'am.
Yeah. Okay. So tan theta is opposite side by adjacent side, which is simply y2 minus y1 by x2 minus x1. And this is the classical formula for slope, which is slope m is equal to y2 minus y1 by x2 minus x1. So children, I hope you remember from your previous Janma, that is your previous class, that's before Corona, you must have learned about this formula. Hope you remember and please do continue to remember because you'll be using this formula number of times. Okay, so how many different ways we have found we can find the slope. One way, if you know the angle, simply apply tan theta will give you the slope. If you know any 2 points on the straight line, use this formula y2 minus y1 by x2 minus x1 to find the slope. And if you know two parallel lines are there, then the slopes are equal. If you know two perpendicular lines, then the product of slopes is going to be -1. So this is how we are going to go with finding the slopes. Now, how are we going to use this for our further problems? Ma'am, slide I think got stuck, not moving. Further problem. Ma'am?
Ma'am, please escape. Press escape.
Yeah. Okay. Nothing is happening, ma'am.
Or you may stop sharing and then start it again, ma'am.
Okay. Got stuck actually.
You can start it again, ma'am.
Start the slide. Okay. I have to share my screen, right, ma'am?
Yes, ma'am.
So that was a small interruption. There was a little technical issue. Hope we'll go ahead nicely. Yeah. So here we have seen that the slope m is equal to y2 minus y1 by x2 minus x1. Now just immediately let's use this formula before it goes off from our mind. So we are given 2 points here and we are asked to find the slope. Find the slope of the line passing through 2, 4 and 6, 8. Now take the first point as x1, y1 and the second point as x2, y2 and simply put it in the formula slope equal to y2 minus y1 by x2 minus x1. So it is just the difference of the y coordinates, that is 8 minus 4 and 6 minus 2. This will just give you 4 by 4, which is 1. So this is how we are going to use this formula. And here we can also use this formula to find certain unknown values in the coordinates. Here we are given 2 coordinates 2, 5 and x, 3. And you can see there is one unknown value here. Now, how are we going to find this unknown value? Let us take these 2 points as x1, y1 and x2, y2. And again, apply the same formula y2 minus y1 by x2 minus x1. It is 3 minus 5 by x minus 2. And the slope is given in the question itself. Here we are given the slope as 2. Now here, so on simplifying this, we get 2 by x minus 2 as 2. And so on simplifying this, and taking this x minus 2 to the right side, we will get 2 is equal to 2 into x minus 2. And so cancelling 2 on both sides, we have 1 is equal to x minus 2. And bring the minus 2 to the other side, we have x is equal to 1 plus 2, which is 3. So that's how you can find the unknown value in a particular set of coordinates. Okay. So I mean, these would be very short answers for you in your examination. Now let's go to the more interesting part of straight line. As our introducer, Dr. Krishna Kumar sir has told, straight line has different forms. Now you're going to see all the Dashavataras. Okay, not 10 avataras there, but there are certain avataras for this. So the standard form of the straight line is going to be x plus by plus c equal to 0. The first avatar would be slope intercept form, which is y equal to mx plus c. The second avatar is intercept form x by a plus y by b equal to 1. Third avatar is normal form x cos alpha plus y sin alpha equal to p. Fourth form symmetric form x minus x1 is to cos theta equal to y minus y1 is to sin theta. And this is 2-point form y minus y1 into x2 minus x1 equal to x minus x1 into y2 minus y1. And we have the most famous uh, form, that is point slope form, which is y minus y1 equal to m into x minus x1. Don't worry, we'll be learning about each of these forms in detail now. Now let us start with the basic form, that is the standard form. Now the standard form is going to be of the form ax plus by plus c equal to 0. Here a, b, c are the coefficients. You can have any real coefficient here in the place of a, b, c. Now how do we get the slope? Slope is simply minus b by a. It is just the coefficient of y by the coefficient of a, the negative sign. Why? How do I get this? You will learn in your next lesson, where you will have this form and you will be converting this form into all the other forms. Okay, children? So for now, if you see a line in the form of ax plus by plus c equal to 0, then just remember that the slope is nothing but minus b by a. Now, how are you going to use this? So, suppose there is a question like this. Find the slopes of the line x plus y equal to 0 and x minus y equal to 0. Now, what is that you have to do? You only have to compare the given questions with the standard form and find the value. So here if I take x plus y equal to 0 and compare it with this standard form ax plus by plus c equal to 0, then a would be 1 and b equal to 1. Now according to this formula minus b by a, the slope of this particular line would be minus b by a, which is minus 1 by 1, which is minus 1. Now take the second line x minus y equal to 0 and again compare this with the standard form. You will see that a is 1 and b equal to here minus 1. We have to take along with the sign. Okay, coefficient means along with the sign. So here b is minus 1 and so the slope m2 is minus b by a, which is minus of minus 1, which will be 1. So here what do we observe? We observe that both the slopes are of different sign, and if I multiply these two things, I'm going to get minus 1. So actually the question ends here. You're asked to find the slopes. The slope of the first line is minus 1, the slope of the second line is 1. Fine. Great. But one observation you can clearly make that if you make the product of these two things, it's giving us minus 1. Now, if the product of two lines is minus 1, what can you talk about the line? The two lines are perpendicular to each other, is it not? So I hope you remember, if two lines are parallel, then the slopes are equal. If the two lines are perpendicular, then the product of their slopes are minus 1. Now here, let's go into the next avatar, that is the slope intercept form. Now what do you mean by slope intercept? Now here suppose I take x-axis and y-axis like this, and there's a line which is intersecting x-axis and y-axis, and this line is making an angle theta with the positive x-axis in the positive direction, and you have a portion cut by this line on y-axis. Now there is one portion from origin to the point of intersection of the line and y-axis, and that portion we call it as y-intercept. So intercept is nothing that portion on the axis which is cut by the line or intersected by the line. Now here theta is the angle made by x-axis, made by the line with the x-axis, and uh, uh, the intercept is c. Now here what is the slope? The slope is y2 minus y1 by x2 minus x1, as we have learned from the definition. And so here suppose I take the 2 points, this point would be x comma 0 on x-axis and this point would be 0 comma c on y-axis, is it not? So here what is the slope? The slope m here is y minus c by x minus 0. Now if you take the denominator to the other side, you will obviously have mx is equal to y minus c, and take the minus c also to the left side, you will have y is equal to mx plus c. Now here you can see that m stands for the slope, which is tan of this particular angle here, and c is the y-intercept. So the slope intercept form is what? The slope intercept form is y equal to mx plus c. So here we call this as slope intercept form because we are using the slope m and the intercept c here. Okay. So remember children, slope intercept form means what? Y equal to mx plus c. See, we are going to learn all these forms because whatever data is given, using that data, we need to find the equations of straight line. So our ultimate aim is going to be forming the equations of straight line. For that, whatever data is given, using that data, we have to find the line. Now here, suppose the slope and intercept are given, y-intercept are given, this is how you will find. Okay, so this is how y equal to mx plus c will be found. Now here, suppose we have the value of c is equal to 0, that is the intercept is 0. When does the intercept become 0? when this line is passing through origin, something like this. Now it is passing through origin, it is not making any intercept on y-axis, and so the c is 0. Now what will happen to this line now? This line is nothing but y equal to mx, because the intercept is 0, we only have the slope. So the equation of the line passing through the origin with slope m is going to be y equal to mx. Okay, so whenever you find a line of the form y equal to mx, or y equal to 2x, or y equal to 5x, immediately you should get a thought that that line is passing through the origin. This would help you to solve your bids in your competitive exams. Now let us see one example using this form. You have to find the equation of the straight line making an angle 120 degrees with positive axis measured counterclockwise and passing to the point 0, minus 2. Now here the slope m is equal to tan 120 degrees. You will learn more about how to derive tan 120 degrees in your trigonometry section, that is in mathematics 1A. When we speak about trigonometry, you will learn how to derive this value of tan 120 degrees. It's going to be 180 minus 60. All that stuff you will learn in trigonometry. Now for now, this tan 120 degrees is going to be minus root 3. Okay, now I got the slope now. I also have a point called 0, minus 2. Yeah, now from 0, minus 2, what do I understand? It is a point on y-axis, and so the intercept C is nothing but minus 2. Now here I got slope and I have got y-intercept. So let me use the slope intercept form, which is equal to y equal to mx plus c, where m here is minus root 3 and intercept is minus 2. So y equal to minus root 3x minus 2, or you simply take all the values to the left side, you will get root 3x plus y plus 2 equal to 0. Right. Now let's go to the another avatar, which is point slope form. Now what is this point slope form? As the name suggests, we are going to have a point and a slope. Let us see. So we have got x-axis and y-axis on which there is a straight line like this, and a straight line called L, and on the line we have got a point called A of x1, y1, and it is making an angle theta, whose tan value, if I take, becomes the slope. So what are the data that I've got in this form? I've got a point and I've got the slope. That is why it is called point slope form. Now if I have these two things, how do I get the equation? So again here the slope is y2 minus y1 is equal to x2 minus x1. Is it not? Now here the other point, let me take a point on this particular line. You must have learnt in locus, any point on a line L can be taken as p of x comma y. Now suppose I take any point on L as p of x comma y and the other point as a of x1 y1. The slope would become y minus y1 by x minus x1. Now take the denominator to the left side. We will get m is equal to x, m into x minus x1 equal to y minus y1. And on simplifying this, simply flipping it, LHS and RHS, we get y minus y1 is equal to m into x minus x1. So this is how we get the point slope form. So what is point slope form, children? It is y minus y1 is equal to m into x minus x1. Now here, let us use this and solve a problem. Find the equation of the straight line which makes an angle 135 degrees with positive x-axis measured counterclockwise and passing to the point minus 2, 3. So we are given an angle and a point. So if you are given an angle, the first thing that we would do is to find the slope. So what is the slope of the given straight line? It is simply m equal to tan 135 degrees, which is going to be a value called minus 1. Tan 135 is 180 minus 45, which is minus tan 45, which is minus 1. And we are also given a point minus 2, 3. So Now I've got the slope and a point. Now I'm going to use this point and a slope in this point slope form y minus y1 equal to m into x minus x1, where this point will act as x1 y1 and this will act as the slope. Now on simple substitution, in the place of x1 y1, we are going to put minus 2 comma 3, and in the place of m, we are going to put minus 1, and this is how we get the equation. So y minus 3 is equal to minus 1 into x plus 2. Multiply with minus, you will get minus x minus 2. Bring minus x to the other side, you will get plus x plus y minus 3 minus plus 2 will give you minus 1. And so what is the equation there? X plus y minus 1 equal to 0. That is the required equation. So my dear children, this is how you will find the equation of this straight line when you know the slope and the point. Okay, so now let's go to the another avatar. Another problem where you use this form. Find the equation of the straight line passing through the origin and making equal angles with the coordinate axis. Now, if they're making equal angles, then the total 90 degrees is divided into two particular equal angles, that is 45 and 45, and it is passing through origin, which means the point is going to be 0 comma 0. And now the point slope form of the equation would be y minus 0 is equal to 1 into x plus 0, which is y equal to x. You can actually use y equal to mx also because it is passing through origin. M will be 1, and simply you can put y equal to mx, that is y equal to 1x. Like that also you can get the equation. So if we are, how we are getting this 45? Let us see. So we have got x-axis and y-axis. Now this line is passing through origin, and we have said that it is making equal angles, which means the angle made with x-axis is 45. The angle made with y-axis is also 45. So it is dividing the angle between x-axis and y-axis equal. That's why we say each angle is 45. So, dear children, it is not only simply one method that you can use. You can use any one method to get the equation. So here I've used point slope form. You can also use actually y equal to mx plus c form, and you can simply get y equal to x. Now let us see another avatar. You have been drawing so many straight lines in your 10th class. Now here I've got 2 points on this straight line. Now what is the data here? Initially it was point slope form, then it was intercept and point form, intercept and slope form. Now we can see 2-point form where there are 2 points on the straight line, which are a of x1 y1 and b of x2 y2. Now how do we get this? Now here there is a theorem which proves the equation of straight line. Now here the equation of the straight line passing through 2 points a x1 y1 and b x2 y2 is x minus x1 into y2 minus y1 is equal to y minus y1 into x2 minus x1. Now how do we get this? As you know, there are 2 points which are given. The first thing that we would do is to find the slope of the line. You know from 10th class itself, the slope of the line is y2 minus y1 by x2 minus x1. Now in the point slope form, we have learned y minus y1 is equal to m into x minus x1. In the place of m, we are going to substitute this formula of slope, and hence we get the 2-point form. Now this 2-point form is another famous form used while finding the equations of straight lines. So dear children, please remember this form: y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Okay, so here in this form, we have x1 not equal to x2. That is, the denominator is same. We are going to get some value here. Now, what happens if the denominator becomes 0? That is, if x1 is equal to x2, what will happen? What will happen if x1 equal to x2? This denominator is going to be 0. Yeah. So if denominator is 0, if you use this equation, this 0 will go that side and simply make the LS 0. And 0 by this y2 minus y1 will make it 0. Simply we're going to have x minus x1 or x equal to x1. Exactly speaking, what is this x equal to x1? It is nothing but a line parallel to y-axis. If you have a line parallel to y-axis only, you will have all the coordinates of x equal. Is it not? So here, if you have the x coordinates equal, you will get a line parallel to y-axis, which is of the form x equal to x1, which you have learned previously. So either the case, if x1 not equal to x2 or x1 equal to x2, this is called the 2-point form. So what is a 2-point form? It is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Okay, so 2-point form, you have got 2 points, right? So using this, there are many corollaries that you can speak about, but I'm here giving you one or two. Now you can use this form to prove that 3 points are collinear. So do you remember, children? You must have used the area of triangle formula to show that 3 points are collinear. Now here there is another method where you can use 2 points, find the equation of the straight line, and substitute the third point in that and see if it satisfies the equation. That is, if it makes the equation 0, then they are called collinear. Collinear means what? All lying in the same straight line. Is it not? So co-linear. The very word tells you that all the 3 points are lying in a straight line. So whenever you want to prove that 3 points are collinear, here you have another method. The first method you might have been using was finding the area of the triangle using all these 3 points and showing that the area of the triangle is 0. That's also correct. Yes, if you can't use that formula, you have another method here. What you have to do here? Simply form the equation of the line passing through A and B. You will get an equation called AB bar. Now, in this AB bar equation, you substitute the third point C and see whether it satisfies the equation or not. If it satisfies, you say that they are collinear. If it is not satisfying, you say they are not collinear. Now, children, you will also be learning a chapter called matrices, a very, very interesting and easy topic called matrices in your mathematics 1A in the coming classes. Now, this is a matrix form which you will use in your M.SAI and other competitive exams, where you can simply take the value of the debt and put the first and second columns as the x and y coordinates, and the third column as 1. If you get the debt value as 0, you will say the 3 points are collinear. If the debt is not 0, they're not collinear. So this shortcut you will use in your exams for competitive. Right. Now, the same debt form I can use to form the equation of the straight line also, simply by putting the first column as x, x1, x2, second column as y, y1, y2, and the third column all 1, and putting the debt value equal to 0. Expanding this debt, you'll be getting the equation of straight line. Now here, let us use this and find the equation of straight line. So you are asked to find the equation of the straight line passing through 1 comma minus 2 and minus 2 comma 3. So what is the first thing? Just simply find the slope of the straight line. Hope you remember the formula y2 minus y1 by x2 minus x1. Apply that formula for these 2 points by taking the first point as x1 y1 and the second point as x2 y2. Substitute in this, you will get the slope. Now hence the 2-point form. You have 2 points here. You use the 2-point form. The first point is x1 y1, the second point is x2 y2. So here y plus 2, I'm using this as y1, is equal to the slope here 3 plus 2 by minus 2 minus 1. 3 minus or minus 2 becomes plus 2 minus 2 minus 1 into x minus x1. X minus x1. So here, on simplifying this, what do we get? Y plus 2 is equal to 5 by minus 3 into x minus 1. Now simply take minus 3 to the left side and try to simplify this. You will get 5x plus 3y plus 1 equal to 0. This is how you can find the equation of the straight line using 2-point form. Now here we have another example where we are asked to prove that these 3 points 111, 215, -3, -5 are collinear. Collinear means all lying on the same straight line. And we will also find the equation of the straight line containing them. So let's go other way around. First, let us take, so what we have to do here, we have to take, we are given a line on which there are 3 points. We have to prove that these 3 points are collinear. Okay. So here, what are we going to do? Let's form the equation of the straight line with BC. I'm going to take B and C, these 2 points, and form the equation. First, let us find the slope using the formula y2 minus y1 by x2 minus x1. I got 4 as the point. Now, let's form the equation of the straight line using point slope form. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. So here, this is x1 y1 and this is x2 y2. On substitution, I got y plus 5 is equal to 4 into x plus 3. And on simplification, I got the equation of BC now. The equation of BC is 4x minus y plus 7 equal to 0. So this is the equation of the line passing through B and C. Now let us see if this point A satisfies it or not. So let me substitute 1, 11 in the above line. What do we get? Just simply see, in the place of x, I am substituting 1. In the place of y, I am going to substitute 11. On substituting and simplifying, you can see this is 4 minus 11 is minus 7. Minus 7 plus 7 is giving us 0. So what do you understand from this? We understand that all these 3 points are collinear. That is, they're all lying on the same straight line. Okay. So this is how we see that 2-point form is used. Now here we have the another avatar, that is the intercept form of a straight line. As I've told you previously, intercept is nothing but that portion on x-axis cut by the line becomes x-intercept, which is denoted by small a here, and the portion cut on y-axis is b. This is called y-intercept. This portion is called y-intercept and this portion is called x-intercept. The notations here are x-intercept is small a and y-intercept is small b. Now, how do we get the equation? The intercept form of the equation is x by a plus y by b equal to 1. So the equation of the straight line, which cuts off non-zero intercepts a and b on the x-axis and y-axis respectively, is x by a plus y by b equal to 1. This is another famous form that we have to remember. Now, how do we get this? The straight line L, which cuts off non-zero intercepts a and b on the x-axis and y-axis respectively, meet x-axis at a equal to 0 and 0 equal to b. Therefore, the slope of the line L is equal to y2 minus y1 by x2 minus x1, which we have already learned in the previous slide. Now here, on x-axis it is a comma 0, on y-axis it is 0 comma b. Is it not? Now this becomes x1 y1 and this becomes x2 y2. And on substitution of these 2 points in this formula, we get b minus 0 by 0 minus a, which is minus b by a. Now let me use the slope intercept form, which is y equal to mx plus c. In the place of m, I'm going to put minus b by a. And in the place of c, that is y-intercept, we're going to put b. Now take a onto the other side and try to simplify. We get x by a plus y by b is equal to 1. Okay. So this is how we get the intercept form of a straight line. So we call it intercept because here a and b, small a and small b, are the intercept of the straight line which they make with x-axis and y-axis. Oh, I'm sorry, I went to the very first slide. So we're talking about the different forms. The slope intercept form, point slope form, then we have 2-point form. Yeah, we were talking about the intercept form now. So here we have an equation, we have a particular problem using this intercept form. Find the equation of the straight line which makes intercept. So sum is 5 and product is 6. So this is one particular famous problem always asked both in public examination as well as your competitive exam. So here the sum of the intercept A and B is 5 and the product is 6. Now how are you going to solve this? This is how we are going to solve. Excuse me. So if A and B are the intercepts of the line on the axis of coordinates, then what is the hypothesis given? The hypothesis here is sum is 5. Now if I take intercepts as A and B, the sum is going to be A plus B. So A plus B is equal to 5 and the product AB is going to be 6. So A plus B is equal to 5 and AB is equal to 6. Now solving these equations for A and B, how do we solve? I've got the sum here, so I want to find the difference. Now how to find the difference? I've used an algebraic identity called A minus B whole square is equal to A plus B whole square minus 4AB. Here A plus B is 5, which is given. A into B is 6, that's given. So 5 square minus 4 into 6 becomes 25 minus 24, which is 1. Now here A minus B whole square is 1. So A minus B is going to be plus or minus 1. And already in the hypothesis, we have A plus B equal to 5. Now if you solve these two equations, A minus B equal to plus or minus 1 and A plus B equal to 5, then we can cancel B and B and you get 2A is equal to 6 if I take plus 1. 2A will be 4 if I take minus 1. So if I take 2A is equal to 6, I would get A equal to 3 and B equal to 2. Is it not? This portion I will get. And if I take, this is what I will get. And if I take uh, um, uh, minus 1 here, I'll get 2A is equal to 4. And if 2A is equal to 4, then A equal to 2 and B equal to 3. Is it not? So here, if I take A equal to 3 and B equal to 2, then the equation of the line would be x by 3 plus y by 2 is equal to 1, because A and B are 3 and 2 here. So on simplifying this, simply take 3 to LCM, you will get 6. And so 2x plus 3y minus 6 equal to 0. If it is other way around, that is if I take A equal to 2 and B equal to 3, then the equation of the line is x by 2 plus y by 3 is equal to 1 or 3x plus 2y minus 6 equal to 0. So like this, we will be getting two equations if we have the sum as 5 and product as 6. Okay, so let's move on to the next one. So this is another example where we have to find the equation of straight line passing through A minus 1 comma 3 and parallel, also perpendicular to the straight line passing through B2 comma minus 5 and C4 comma 6. Now here I am going to take the first part. The first part here is a line parallel to the line which is passing through B and C. So I've got a line which is passing through A of minus 1 comma 3 and I've got another line which is passing through B2 comma minus 5 and C4 comma 6. Now these two lines are parallel. That's what is given in the first bit. Now if I take that these two lines are parallel, now let us find out the slope of BC. Now what is the slope of BC? As you know, slope is y2 minus y1 by x2 minus x1. Here let us take this as x1 y1 and this as x2 y2. So this becomes 6 minus or minus plus 5 by 4 minus 2, which is 11 by 2. The slope of BC here is going to be 11 by 2. Now, if these two lines are parallel, in the first case itself, we have seen that two lines are parallel, then the slopes are equal. So the slope of BC is 11 by 2. The slope of the line passing through A will also be 11 by 2. So here, let us use the slope, point slope form of the line y minus y1 is equal to m into x minus x1. Okay, so here if I use that particular format, y minus 3 is equal to 11 by 2 into x plus 2 and take this 2 to the other side, it becomes 2y minus x is equal to 11 into x plus 2. So 2y minus x is 11x. Just simply multiply 11x plus 22. And so 11x minus 2y plus 22 minus 6 goes this side, becomes plus 6. The equation of the line is, required line is 11x minus 2y plus 17 equal to 0. Now similarly, you can find
Madam.
pardon ma'am.
Can we go to the practice session? We will take up this problem in the next session.
Okay, just
We'll continue all this in the next session.
Okay, ma'am. Okay, ma'am. So this is the homework for you children. It is exercise 3A, which is in page numbers 35, 36, and 37. And thank you. Thank you for listening so patiently. Hope you will go through the slides once again and get to know of different forms and make a note in your notebook and try to this exercise. Thank you. Thank you so much.
Thank you very much, madam. I am sure the lesson has gone collinear with the students' learning, their understanding, and their practice. I am sure they will be practicing all the problems at home and will definitely practice and be ready for your next session, madam. Thank you very much for the interesting session. Thank you, ma'am.
Thank you very much, sir.